Good morning, students. Now I am going to discuss about a topic of sections of solids. First of all, we have to learn what is meant by sections of solids. An object or solids are assumed to cut by an imaginary plane to understanding the internal features of an object. So, if you observe the internal combustion engine, its outer look is different, internal parts is different. So, if you cut the IC engine, its internal parts are visible. The action of cutting is called sectioning the solid, and the imaginary plane is called sectional plane. So, already we know what is meant by solid, how many solids are there, what is meant by plane, what is meant by solid. Already we know about all these things. We have learned in first year 1-1. So now I am going to discuss about the square prism. You know about the prism very well. Prism contains two bases. One is top base, another one is bottom base. So here this is the prism. Here two bases is there, top base, bottom base. These are the vertical faces. Here this one, this is one face, second face, third face, fourth face. Here only four faces. Why here only four faces is there? Only here number of sides are 4. So every side contains one face. This one first side, this is first face, second face, third face, fourth face. So another solid, this one is hexagonal prism. We know very well prism contains two bases. Here also this one is top base, this one is bottom base, this one is rectangular face, second rectangular face, third one, fourth, fifth, sixth. Here this one is hexagonal shape. So total 6 sides are there. So faces is also 6 faces. So here these are pyramids. Pyramid contains only single base, and top point, this is called apex. This is base point. Here triangular faces is there. In prism, these are rectangular faces. Here the pyramid, these are triangular faces. This is the major difference between the prism and pyramid. Prism contains two bases, pyramid contains single base with apex at the top point. Apex at top point. So here now I am going to discuss problem is given in sections of solids. So here the question is, a square prism base 40 mm, side axis 80 mm long, has its base on the HP and its faces equally inclined to the VP. It is cut by a plane perpendicular to the VP, inclined at 60 degrees to the HP, and passing through a point on the axis 55 mm above the HP. Draw its front view, sectional top view, and another top view on HP parallel to the section plane. So here a square prism is given, that is, this one is the square prism. Here base of side, this one is the base, this bottom side, this side length is given already in the problem, that is 40 mm, and the height of the prism is 80 mm. First of all, I am going to draw the true shape of an object, that is square, and then I am going to draw front view of an object. Here in the question, what they given, its faces are equally inclined to the VP. Faces are equally inclined to the VP. This is the imaginary plane, means this is the vertical plane, this is the horizontal plane. The object is placed like this. This is the starting position of an object. The faces are now parallel to the VP. This face is parallel to the VP. The backside face is also parallel to the VP. In the question, what they given, faces equally inclined to the VP. This one is the face. Now this one is parallel to the VP. Now I am going to place these faces are equally inclined to the VP. This is the inclination of the VP. This is the inclination position of the VP. This one is the longer edge. I am placing this one is equally inclined to VP. First of all, I am going to draw the square prism, top view. This is the XY reference line, auxiliary reference line. This one is HP, and here this one is VP. Now we have to place the angle at an angle of 45 degrees with the VP. So the side of length 40 mm. This is the second side. This is the third one. This one is fourth one. So these are the corners. Now I am writing names of the corners A, B, C, D. So prism contains two bases. Already this one is a top base and the bottom is also one more base is there. So I am placing bottom base names E, F, G, H. Okay. Then again we have to extend these points up to reference line. Up to reference line. The question, the prism height is 80 mm. Axis of the prism is 80 mm. So here first we have to draw the axis of the prism, that is 80 mm. This is the axis of the prism, and then we have to extend these points. We have to extend these points up to 80 mm. This is the final front view of an object. This one A dash, here B dash, here C dash, here E dash, this one is H dash, this one is G dash. The cutting plane and what they given in the question, a sectional plane passing through at a distance of 55 mm from the HP. 55 mm. This is the HP passing through at a distance of 55 mm from the base. Base means here, this is the HP. This is 55 mm point. Just we have to draw a dimensional line at a distance of 55 mm. Draw a point at here. Now I am mentioning the distance. I am mentioning the distance 55 mm. This is the dimension 55 mm. So now I am going to draw a sectional plane at an angle of 60 degrees with the HP. Section plane passing through an angle of 60 degrees with the HP. This is the section plane. Section plane passing through an angle of 60 degrees with the HP. Okay. So that section plane cuts the front view in different points. Those are 1 dash, 2 dash, 3 dash, and back side also 2 points is there, that is 4 dash and 5 dash. So after drawing the sectional plane, we have to remove this portion, and then observer can observe from top view. He will get the sectional top view of an object. This is the removed portion, and this one is the final remaining portion of an object. After drawing a sectional plane, this is the final front view. This one is removed by using a sectional plane. So now I am going to extend these cutting points to downward. So 1 dash 2, I am going to extend this point to downward. This one here 1, 2 dash 2, 2, this one B, this one 2, again this point, same point coming in same line. So here one more point, that is 5, and third point 3 and 4 are coming like this. This one is 3, this one is 4. This is the final sectional top view of an diagram. Final sectional top view of an diagram. So after that, we have to hatch the final sectional top view of the diagram. We have to hatch the sectional top view to maintain a distance minimum 2 to 3 mm. Equal distance. We have to maintain equal distance between the hatching lines. This is the final sectional top view. And then we have to draw true shape of an object. For drawing a true shape of an object, first of all, we have to draw an auxiliary inclined plane which is parallel to the sectional plane. This one is y1, x1, y1. So from this sectional plane, from this sectional cutting plane, we have to extend, we have to draw the perpendicular lines. from the cutting points. From the cutting points 1 dash, 2 dash, 5 dash, 3 dash, comma 4 dash. And then take the distance from this base point to this here and project this distance so from base h dash to 2. Take the distance with compass h dash to 2. Okay. Again h dash to 5. H dash to 5. Again from base to 4 3, base to 3. Next base to 4. These are the points here. This one is 1, 2, 3, 4 and 5. These 5 points are joined by a line. Here also we have to hatch this. This is the final true shape of an square prism. So and then we have to hatch this area. Here also at least maintain 2 to 3 mm gap between the hatched lines, equal distance. This is the final true shape of an square prism. This is the final diagram with the dimensions. Here now I am placing the length of the side 40 mm. 40 mm. Total height of the prism 80 mm. Okay, that is first question.